proportions? Well, the first thing, you better know what a proportion is, so I better tell you. When we say the word proportion, all we really mean is the equality of two ratios, or basically the equality of two fractions. So if you have one fraction equal to another, that right there is a proportion. We by the way, we deal with proportions all the time. All the time. You ever had a model car before? Have you seen a model car before? You ever seen a blueprint of a building before? Is the blueprint of a building the same size as the whole building? That'd be pretty stupid, right? Because why not build the whole building if the blueprint's the same size? That'd be ridiculous. Why have a model of the car that's the same size as a car? But when you look at the model car, the door's the same proportion as the hood, right? It's not like significantly bigger than the hood, because you want the model car to look just like the regular car, don't you? So if you shrink the hood, you also got to shrink the door. You shrink the door, you got to shrink the tires, and then shrink the engine by the same proportion. You ever seen that before? So everything's in the same proportion. It's just that it's a lot smaller in every way. Those two things are called in proportion to each other, because if you create a fraction out of one of them in relation to like a door and a hood, surface area wise, and a relationship between the model car, it's going to be exactly the same fraction. It's going to equal each other. Just they're going to be a different value on the numerator and denominator. So basically, when we have the equality of two fractions or ratios, we have what's called a proportion. So the equality of two ratios or fractions. Let me give you, for instance, I'll include up here rates as well. The equality of two rates, ratios, or fractions. Let's say you went 250 miles in 5 hours. How far did you go in 1 hour? Probably. Let's pretend you went a constant speed the whole entire time. 50. You went 50. So would you agree that 250 miles over 5 hours is the same thing as 50 miles over 1 hour?
Yeah.
Is that true?
Yeah.
That's a proportion. It's just the equality of two fractions. In general, here's how proportions are going to look for you. In general, we simply have one fraction equal to another. So like A over B equals C over D. That's a proportion. Now here is the amazing thing about proportions. This is going to allow us to solve equations pretty easily in just about 5 minutes. Check this out. Every single time you have a proportion, the cross product, have you ever heard of cross multiplication before?
Yes.
You ever heard of that? Cross multiplication isn't the simplification we've been doing. That doesn't work. But multiplying across an equation, do we have an equation up here?
Yeah. Yes.
That equal sign says equation. If we multiply across the equation, that's the worst dotted line I've ever seen in my life. How about you? Pretty bad? We'll fix that. It's hard to do that way. If you multiply across the equation, those are called cross products, or the cross multiplication. Product simply means multiplication. The cross products will and must be equal in proportions. So, in all proportions, the cross products, that means cross multiplication, must be equal. For us in this example, that means that if you have these fractions, there's a very easy way to get rid of the fractions. This is so beautiful. You don't have to deal with fractions if you have a proportion. Proportion is just one fraction equal to another one. So if you have that, you simply take the A times D, and it must equal B times C. That's got to be true. The cross products must absolutely be equal if you have a true proportion. By the way, this allows you to check to see if a proportion is true. For instance, we can verify that this is a true proportion. If you do the cross product here, you would get 250 times 1. Do you see where those numbers are coming from, folks?
Yeah.
250 times 1 equals, what's it got to equal?
5 times 50.
5 times 50. See where those numbers are coming from? What's this side give you?
250.
What's the other side give you?
250.
Are they equal?
Yeah.
That means that I started with a valid proportion. If they ever come out to be unequal, then you know that that proportion was not a true proportion or not a valid proportion. Would you like to see a couple more examples of that?
Sure.
So right here, you're verifying whether these proportions are accurate or not, basically. So let me give you a couple examples. We're asking, is 3/4 equal to 9/12? Now, I'll grant you, there's a couple ways to do this. You could just simplify this fraction and see if it's the same. But if you have some fractions that are kind of nasty looking, or you don't really want to simplify any fractions, you could check it with a cross product. So for instance, a cross product would say you multiply these two, you multiply those two, you get 3 times 12 equals 4 times 9, and you check to see if they're the same. Are they the same on both sides of your equation?
Yes.
Yeah, you get 36, you get 36, you put a little check mark, signifying, yeah, that's a true proportion. We'd say, yeah, true proportion, not a problem, without a doubt. How about this one? Why don't you check this? See if this is a true proportion. Do the cross product and see if they're equal. And do one for me when you're done with that. Try this one. Is getting 50 miles for every 3 gallons the same as getting 250 miles for every 12 gallons? You can check that with the cross product. So use the cross product. Again, there are several ways you can do this, but use the cross product to figure out whether these things are actually true proportions. Cross multiply, figure out if they're the same on both sides of your equation. If they are, then yes, true proportion. If they're not, then no, it's not a true proportion. Remember, I do want you to start bringing a calculator to class because I'm going to be showing you some things on how to use that appropriately in the future. I don't want to leave you out. All right, let's see how this goes. So first thing we do in every case, if you're trying to check whether a proportion is actually a valid one, which means a true proportion, you're going to cross multiply. Again, there are several ways you can do this. You could reduce both fractions and see if they reduce to the same thing. That'd be fine. Or you can use a cross product. I think that's a little quicker now that you have a calculator. So if we cross multiply, we're checking 3 times 90 and 15 times 18. What's 3 times 90?
270.
What's 15 times 18?
270.
So is that a true proportion?
Yes.
A little check mark because they were equal, for sure. How about this one? Is 50 miles for 3 gallons the same as 250 miles for 12 gallons? I don't know, but we can easily check. If we multiply the 50 times 12, we're ignoring the units for now. Is that the same as 3 times 250? Well, I don't know. What's 50 times 12?
600.
What's 3 times 250?
750.
Are those the same?
No.
So you put no, that's not a true proportion. It's a nice and easy way to check those though, right? Instead of having to reduce both fractions, you just do the cross multiplication and check whether they're equal or not. If they are, great, it's a true proportion. If they're not, then no, you don't have the same thing. How many people feel okay checking these proportions? Now this is all fine and good, but honestly where the beauty of this comes in is you're able to solve some equations pretty nicely with this idea. Let me show you what I'm talking about. So we can use the fact that we've got proportions to solve equations. So I'll put up here, we're going to solve some proportions. For example, now again, there are different ways you can do these problems. I'll tell you that right now. There are different ways. I'm just giving you another tool that you can use. And it's a very handy tool. It's a quick tool because you don't have to deal with fractions. It's a very nice tool. You ready to deal with this? So if you have 5/9 equals x over 45, firstly, do you have a proportion?
Yes.
Yeah. If you ever have one fraction equal to another fraction, it's a proportion, okay? Now, it could be a false proportion like this one, but it's still technically, that's a proportion. Now, because we have the x, well, we can't tell whether this is true or false because we don't have a number up there right now. But what we can do is use this idea of cross products to solve for what that number needs to be in order to make it a true proportion. That's the idea. You're solving for what that number needs to be in order to make it a true proportion. You guys know the whole cross multiplication thing? Cross product? Can we find the cross product here? What two numbers need to be multiplied together?
5 and 45.
Okay, so we do 5 times 45. It does not matter what side that goes on for your equation. It doesn't matter at all. As long as you're multiplying these two and these two. So you could have 5 times 45 equals, what's the other one? 9 times x. Okay, great. 9 times x. You could have it here, or look at the board. You could have it reversed. Either way, it doesn't matter. Okay? It doesn't matter at all.
Before you do that, can you reduce it?
Like this fraction?
Yeah, well, like the 5.
Oh, I see.
You know what I mean?
You mean, I'm so glad you asked that question. Does this simplify like this one would? That's the question, right? That's the question. Do you remember all those times I had to, and you probably think, well, that's silly. Why are we doing this? All those times I had to do this. Remember all those times I had to do that? I said, you can't simplify unless you can do that, right? And then, sure, you can do that. Absolutely, you get x over 81. Not a problem. Can I do this?
No.
Does that mean the same thing?
No.
So can I simplify? Can I simplify here?
No.
No, I can't. Because I can't make that one fraction. Does that answer your question? That's a great question. Thank you for asking that one. Do you see why not, though? If you can't make one fraction out of it, if you don't have multiplication, you can't simplify it. So right here, that actually is a lot of people's mistake. They go, oh yeah, well, shoot, I'll just do this. Would that change your answer, do you think? Yeah, that gives you x equals 1. We're not going to get x equals 1 out of this. So great question. Instead, we say, all right, well, we can't cross simplify. That's not happening here. We can't do that. We can cross multiply. So here we'd have 9x, sure. We'd have 5 times 45. How much is 5 times 45, please?
225.
Equals 9x. And, oh, wait. Hey, have you seen problems like that before? This is kind of cool about proportions. Proportions are two-step problems. You multiply across, and then you divide. That's it. That's all you got to do. So if we divide both sides by 9, of course we do have to do both sides. It is an equation after all. We get x on the right-hand side. And how much is this?
25.
We just solved the proportion. So we can use the fact that these two fractions are equal to each other, the idea that it's a proportion, use a cross product, and then solve for a missing variable. Give me a head nod if you're okay with that problem. Let's try a couple more. I'll give you one more together, a couple do on your own, and we'll move on. Okay, ladies and gentlemen, do we have a proportion?
Yes.
For sure, yeah, we got one fraction equal to another one, that's a proportion. How do we solve proportions? What are we going to do?
Cross multiply.
Great, yeah. Cross multiplication, or if you see the word cross product, you know product means multiplication, right? So cross product means cross multiplication. Hopefully we'll get 16n equals 5 times 9, or 16n equals 45. Let's get rid of the 16. What do you do?
Divide.
Now wait a second. 45 isn't divisible by 16. So when you punch in your calculator, you should be doing 16 divided by, I'm sorry, I said that backwards. 45 divided by 16. Yeah, don't do it the other way. That would be wrong. 45 divided by 16, yes? Can you simplify that fraction?
No.
So you could either leave it 45 over 16, but maybe in the back of the book it doesn't have that. It could have a decimal. So punch in 45 divided by, not a fraction button, but divided by 16. It'll give you the decimal equivalent. How much is it?
2.8125.
Say that one more time.
2.8125.
Unless it asks you to round it, give the whole thing. If your decimal ends, give the whole thing. If your decimal goes off the screen, then you're going to want to round it, and it'll tell you what to round it to. Are you with me on that? So here, if you're going to do this exact fraction is not 2.8. That's not the same thing. This fraction is 2.8125. Now, if this went on forever and repeated, sure, we'd be rounding it right now, and we'd have that approximate symbol. Remember that approximate symbol I gave you? That's what we'd have. But if it doesn't, if it ends somewhere, make sure you put that whole thing. You ready to try 2 on your own? Okay, let's do this. Seven twelfths equals 42 over x. Solve for x. Six over n equals 45 over 124, and I want you to round that solution to the 10th.
Will we reduce it or?
Which one?
1242?
Sure, reduce it and then give it to me as a decimal if you'd like. Problems are kind of nice, aren't they? Go kind of quick for you once you get the hang of it, don't they? I like those two-steppers.
That would be what, 21 over 3?
You know, I don't know. Let's find out right now. If we do our cross product, hopefully on your paper you have 7x equals 12 times 42. You do that 12 times 42 on your calculator, how much are you going to get?
504.
How are we going to solve 7x equals 504 then?
Divide by 7.
Sure. How much is 5 over...
72.
Exactly?
Yes.
Raise your hand if you got 72. Good for you. That's fantastic. Now the next one, we do the same idea. We will cross multiply, so we'll get 45, and notice how even though it's n times 45, I can still put 45n because it's commutative, right? I can switch that around. N times 45 is the same thing as 45 times n. Are you guys with me on that? Okay. Equals 6 times 124. Wow, I don't know how much 6 times 124 is. How much is that?
744.
Lastly, they're big numbers, but you have calculators now. It's great. Divide by 45. Now, it might go on for a while. It might stop, but my directions are round to the nearest tenth. So you can look at your calculator screen. Tell me what your calculator screen says. 16.53333333 forever. So we go 16.5. We look at the next numbers of 3. It says leave that 5 alone. You have 16.5. There's one mistake right now on the board. What is it?
We don't have the little squiggly line for approximating.
Great. So if you put 16.5 equals, technically you're wrong, because it's not equal to 16.5. However, you put this, and then I know you round it. Then I know it's approximately that amount. That's the appropriate symbol you need to use there if you're going to round. Show of hands, how many people feel okay with what we talked about so far? Now there's one more thing we got to look at. So we will wrap it up. Take us about 2 minutes here. What about something like that? Hey, is it still a proportion?
Yes.
Is it still one fraction equal to one fraction? Absolutely. Look, that's one fraction, right? Even though it's got garbage on the top, it's still one fraction. That's one fraction. Can you still do a cross product?
Yes.
Yeah, let's try it. Just be careful. Watch me on the board what we're going to do here. If you do the cross product, sure, on one side I'm going to get 3 times 7. Doesn't matter the side. On one side you're going to get 3 times 7. Nod your head if you're okay with that. On the other side, look what we're doing. We're taking x plus 2 times 8, or 8 times x plus 2. Are you with me on that? 8 times x plus... Is this appropriate to do 8 times x plus 2 like that? Explain why. Yeah, you're right. I do. What this says is, I'm trying to take 8 times this entire expression, right? Not just the x, but also the 2. How do you show not just the x, but also the 2? What do you put on your paper?
2x.
2x. No, we don't put
2x plus 8. How many times 8? 2x times 8.
We put some
Okay.
parentheses. We put parentheses. Because we're trying to say here that 8's getting multiplied not just by the x, but also by the 2. This is going to be our distribution. Do you guys see how we're getting from this problem to this problem? Raise your hand if you do feel okay with that. Yes, no? Okay. How are we going to get rid of the parentheses?
Distribute.
So that's our 8x, what now?
That's 16.
Equals, hey, have you seen problems like that before?
Yeah.
Booyah, we can solve that. How are you going to solve that?
Minus the root of possible.
We're going to get 8x equals, looks like 5 to me. How do you get rid of the 8? So x equals 5/8. You can do 5/8, or you can give me, let's see, 0.6125. I think if you do that on your calculator. Is it?
21.
Yeah.
3 times 7.
So you can leave it 5/8 or give me the decimal there. It doesn't really matter. Could you do the same thing here?
Yeah.
Okay, just make sure when you're doing this, you're giving me 4 times x minus 3 in parentheses first, and 5 times 3 on the other side, just like that. Then you would distribute and solve that down. We'll end there today.